Hi everyone, so this is going to be the fifth video of our HLD series, and in this video we are going to study about the ticket booking system. This particular section is divided into two parts. In the first video we are going to see about the movie ticket booking system just like BookMyShow and District, and in the second one we are going to see event booking system just like Ticketmaster. So before watching this section forward, I will recommend you to watch the concurrency playlist because that topics are really important for understand this whole section. So without wasting any time, let's get started and study everything in depth. So in India, for booking a movie, the one app or one website that is pretty famous, that is Book My Show, and other one that is recently launched, that is District by Zomato. So that's why I mentioned it here. So we are going to see a common design of both of them. Now let's understand the requirement of the whole system. So I mentioned here 7 points. So the first point is pretty important, that is booking of the tickets. So I mentioned it in star. Second point is about the search movies and view details. So understand it a little bit that there is a search bar on a Book My Show or a District app where you can just type about like the name of a movie and it will give you some like all the movies related to that thing that you have typed. And similar to that second point, you can also type the name of a cinema and it will give you the results related to the cinema hall. Now, fourth point is concurrent. So concurrency means the ability to perform multiple actions simultaneously. Simultaneously, when that means that our system is highly concurrent. So let's see that our system is highly concurrent or not. Well, now moving to the fifth, sixth, and seventh point, that is about the payments, comments, and send tickets. So payments means like a payment system that we are going to see in some another video, that is going to be a separate video about the payment, but I mentioned them in the requirements because they are just part of the whole system. Now the sixth point is about the comments and rating of the movies, the comment system that we can study in some another video. And similarly our seventh point, send tickets. So whenever you like book the ticket, you will get some notification and SMS that is a part of our notification system. We're going to see them in some another video. I just write them because they are part of the complete system, but we are not going to study them in depth. Fifth, sixth, and seventh point, we're going to focus on the first 4 points. Now let's understand one approach that I wanted to tell you. So these 2 points are very necessary to understand this whole section. Like, so section means like this first ticket booking and event booking. So let's understand the first point. So first point says that ticket claim after payment confirmed. So what I mean by this point, so suppose there is U1 and U2, there are two users, they click on a seat L1, and what will happen now? They both are able to click on that seat. There is no locking, nothing. They are just going on our seat. They both are able to click on that seat, and after that, what will happen? They will reach on the payments page. So U1 reach on the payment page 1 and U2 reach on the payment page 2. What will happen? Like suppose U1 is the first person, like U1 is performing the transaction on T1 and this is all is happening on T2, like after 1 minute, like you can consider it. And what will happen? Like if the U1 reaches on the P1, then P1 it will perform the transaction and we are thinking that our transaction is successful. What will happen in that scenario? U1 will get the ticket. That is the perfect scenario, the seamless scenario. U1 click on the seat, click on the book button, reaches on the payment page, the transaction was successful, got the ticket. What will happen to the U2? U2, there can be multiple scenarios. Like P2, the payment page will open. Either the transaction will going to be successful or either the transaction is going to be failed. If the transaction is successful, but the seat is already been booked by the U1, then we cannot we cannot allot a seat to U2. So then what will happen? Then we have to refund that money. Now, what will happen if the transaction is unsuccessful? In that scenario, nothing will happen because seat is already booked by the U1, then nothing will happen in that scenario. Okay. Why I mentioned this point, I just wanted to tell you before teaching the second point that these company, BookMyShow and District, they don't use this first point. But this point is not unnecessary. It is an important point because many other companies use this point. Let me explain you a little bit about when you're booking a ticket from an IRCTC website, then what will happen? There are two users. They will go, they are not going to select a seat. They will just going to select like a sleeper coach. Then what will happen? If the user 1 will reach to a payment page, user 2 is also going to reach to a payment page. They both are going to do a payment and like there is a scenario that user 1 will get a seat, but user 2 will not get a seat because like seats are filled now, but user 2 will not get a refund in that scenario. User 2 will get a waiting list number. So this approach is not unnecessary. Like this approach is not unnecessary. This approach is going to be used in some other scenarios, but in that scenario we are not going to give a refund. We will just provide them a waiting list number. So maybe this approach is used in some systems, but I wanted to mention you that this approach is not going to be used in BookMyShow or District. Now what they actually use, let's move to the second point. That is, there is a one user 1 and user 2. They again reach to a seat L1, and what will happen, like again U1 is the person that like performing the transaction the T1 time and reaches first. So U1 will take a lock that I mentioned in a star point here, that the person who is going to come first will get the lock. Now what will happen if user 1 takes the lock on the seat L1, then what happens, that user 2 will not be able to perform anything on that particular seat because that seat is locked right now. Okay, if that seat is locked, then user 1 will reach to that state of P1, reaches to the payment page, and now what will happen, if the transaction is successful, voila, you get the seat. Then what will happen, the user 1 will get the seat T1, but if the transaction was like the transaction is unsuccessful. So there can be multiple questions that I'm going to ask you and figure it out what is going to happen now. So first question is about if U1 didn't get the seat, so now will U2 get a notification? U2 get a notification in that scenario. Now that seat is empty, you can go and book the seat. Like you can go and book the ticket. Will it going to happen? Like do companies provide this? Because U2 is the second person who was going to try, like who is trying on this particular thing. We are going to look at this particular scenario. Other point is, what will happen that if U2 was trying to book that seat and now like he just closes the window and looking like somewhere else, and if that company didn't provide a notification to U2 and U1 again open the window and again book that same seat, and this time the transaction is successful and they got that seat. So the order is something like U1 transaction failed, U2 is in the priority, okay, but like he was not looking at the window right now, so U2 is again not able to book the seat because we didn't provide you a notification in this scenario, and again U1 reaches to that seat and book that seat. So is it little unfair or not? This is the question. First question is about should user 2 get the notification? Second question is about is it unfair or not? So these are the two questions. I want you to think a little bit about them and answer me in the comment section. Now let's talk about the concepts. So this is the most important concept of this whole video. So first I mentioned it here that there is a user who can visit to a BookMyShow, District and Theatre 1. There are three ways to book a ticket. Either you can go to BookMyShow, either you can go to District, and either you can go to Theatre 1, directly to the counter of a movie theatre, and you can book the ticket. So now, when you are going to book the ticket, I mentioned you that there is some sort of a locking that these two companies are using. So what is internally happening? Let me make you understand a little bit. So they are not using their own databases to perform this action. They are using a common database. These all the three units like BookMyShow, District and Theatre 1. These three are using a common database center that is provided by a PVR or some like a booking authority, so that these three are going to use them. Okay, and they are connecting all this this complete data, and they are connecting all this this complete database is going to be connected with them with some APIs. Okay, so what do you mean by APIs? Of course there are some services here, so they don't have the direct access to all of these DB and all. There are some APIs exposed by this PVR or some booking system thing, so that they can BookMyShow and District can connect to SIM, because these particular company booking system will not provide the direct access to all of them. Okay, that's why when you will visit there is a theater and there are multiple seats there, then if you reaches to this particular seat by the BookMyShow, okay, and again on the District app you will see that this particular seat is locked. Okay, so it means that they both are using a common database and these companies are separate. So it means there is some central entity that is taking care of it. That is that central entity that I make in this square box. That is the first point. Now, if they're using a central entity, what will happen? Let's understand something about the theaters first. So, can you like there is a very simple question. If you are on a theater one, like if you there is one user one reaches to the theater one, can that user can book a ticket of theater two from theater one? Is it possible or not? It is not possible. User one, if reaches to a theater one, can book to a ticket of theater one. So it means at theater one there is some access control as well. Okay, so this is the point one, that on the theater one you can book the tickets of the theater one. Now in BookMyShow also, like this central entity also provides some feature like that I provide you to work in northeast and I provide you to work in northeast and like some regions, and I don't provide you some access to like perform, like movies are not working in these theaters, like you are banned for this particular theater. So what can happen, there is some access control that I wanted to tell you this booking system will provide. So theater one will like able to book for the theater ones, but BookMyShow can book for multiple theaters. Same districts can book on multiple theaters. Seats can be booked on multiple theaters. Now, so first of all, let's understand this central entity now. So first of all, I mentioned that like if there is an API call for seat booking, so like how it will go. So first of all, like BookMyShow will go to theater one that I want to book the ticket in theater one. That is like theater one. Now after that, there are multiple screens in that theaters. So like considering there are two screens in theater one, screen one and screen two. In the screen one, there are going to be some timings on which our movie is going to be played. So like there are timing like on 4:15, 6:15, and there should be some movie details. So I mentioned there is one show timings and there will be a table like something like show timings. So it is something like theater one, screen one, timing is going to be 4:15, 6:15, day and time. Okay, and after that a movie ID, so that our movie description we can get with this ID. So what is the whole hierarchy? Theater one is one to many mapping with our screens, and screens are going to be one to many map with our theater timings. And like movie, they are going to be, of course there is a movie column that they are going to be connected with. Now in the screens there is one more thing. Okay, so there is one more spatial table. Okay, so this is an important table that contains multiple columns. I mentioned some columns only. So of course there are some two columns. There are going to be two more columns in this table, in the second table that is here. Theater one, screen one, because there should be some connection. The theater one, screen one, and after that there is a row number. Okay, there will be a number that is our seat number. After that there will be a type that is going to be of a seat type. Okay, or we can just say a row type. Okay, so what happens when you visit to a movie theater, like there are recliner, there are some premium seats, and there are some classic seats. So what happened, there are prices are going to be different, so there will be some price parameter also in this whole table. Now they on that every seat there are three status that I mentioned: free, logged, and booked. And the types are going to be like recliner, premium, and classic. And on that particular seat there is a status, and but for that particular seat there will be price also, they like that particular, either you can like it is up to you now, that either you can set the prices on the basis of the recliner, premium or classic on the basis of the row, or either you can put the prices on the basis of the seats. It's up to you. It's nothing like, it's not that important right now, but these are the two important points that I wanted to mention. So this is how the whole the whole central entity will look like. It is just giving you a little bit of. So there is one question that I wanted to ask you. So like there is one user one visit to BookMyShow app, and what will happen? He chooses the seat L1, and there is one more user 2 reaches to the counter. So user 1 goes to the BookMyShow, log that seat L1, and he is on the payment page. Payment is not yet completed yet. So the question is, will user 2 will be able to see that seat free on in the counter? Because like now you have to think about it, that counter person will get the priority or not. This is the question. Okay, so think about it, that will user 2 get that seat or user 1 will get that seat. This question is related to priority, and think about that how companies resolve this problem. Now let's study the concept 2, understanding the DB relations. So all the above tables that I mentioned in that particular service in that square box are in our relational DB, except the movie that I mentioned. So I mentioned it here, a movie thing. Okay, so I mentioned it that it is in our Mongo or in our non-relational database. Why? So what happened? Like in this whole table, we'll just store the ID of the like movie ID, but we will not store the complete information, and that is going to be our MongoDB or our non-relational like non-relational database ID. Why we are going to store like movies in our non-relational or document type database? Because there can be dynamic properties in our movies. So there can be multiple actors, there can be multiple co-actors, there can be multiple ratings from different companies like IMDb, BookMyShow, District, and like if there is a new vendor come, there can be ratings from them as well. So these are the multiple parameters that are very dynamic according to the movies. So that's why we have to store all the movies in our MongoDB database or in our non-relational database. And again, so this particular ID of the dead document is going to be linked with our relational database. So I mapped, like I make one mapping table here as well. Theater ID, screen ID, time, and movie. So of course, and on what time this movie is going to be played. So I mentioned the ID here. So like here you will just pass the document ID of that movie. So this is a simple relational. All the tables are going to be in MySQL or like a Postgres and any relational database. Only the movie section is going to be in non-relational database. Now moving to the third point, that is about search movie and all the cinema near you. So I mentioned some of the points here. Let's understand them. So the first point that you need to understand is there is two ways to get the location of the user. First way is to get the location by like if user provides the location on the web browser on the or in our mobile application with the simple let long. Second way is to get the location whenever user enter on the BookMyShow district app, we can simply ask like these app usually ask where do you want to watch the movie. So you can just simply choose a city or a state or something like that. You will simply choose that particular city and then you will move forward. So what internally going to work? The first thing that internally going to happen, if you provide the let long, in that scenario, they are going to calculate the let long of a theater. So they already have the location of a theater and you also provide the your let long. In that scenario, they will find the distance between both the let long and they will provide all the theaters that are near you. Like suppose there is some range, there all the theater that are under 100 kilometers, they will provide all the theaters. This is the first approach when you provide the let long. Second approach is when you provide the city. So in the theater, there is a column named city where the city matches the name. You can simply provide all the theaters to them. Second, again, when you provide like the city, there will be coordinate of the city, and you can again like again use the same algorithm to all the theaters that are under 100 kilometers. Then you can just show all the theaters accordingly. Now we are going to talk about the searching thing that are going to be that we see on the top of that websites. So what happened? Like whenever you type like something like ABC and the movie name is ABCDEF, we'll get that movie. If you type something like Delhi and you like misspell the spelling instead of DELHI, if you type DELI, okay, you still get the movie. In that scenario, there are some algorithms that are working internally. Okay, so these algorithms will able to get the nearby results. Okay, so what I mean by the nearby results, so if you type like Delhi and DELHI, so they will find a value that is related, like that the nearest value that is related to Delhi. So they will find the distance between Delhi, DELHI and DELI. They will find the value between them and they will provide all the nearest neighbors related to that. The algorithms are going to work. So there are multiple algorithms. So I mentioned two of them like fuzzy search and soundex search. So algorithm that I was just explaining was fuzzy search, but there are like soundex search work on the pronunciation, like Delhi and Delhi. They are working on the pronunciation. So there are some ML algorithms how they are both going to be pronounced on that basis. They can provide you the data. So companies are using different algorithms according to their use cases. Now let's study the concept for high concurrency. So before like watch this particular section, I already recommend you to watch my concurrency playlist. Optimistic means that you are saying that there are problems while reading in the system and we are saying it's fine. Okay, there is no worries. You do dirty read, you can do repeatable read. Okay, it's fine. And the pessimistic is saying I will make sure that you will not do dirty read, you will not do repeatable read, and according to the scenarios, data will provide all these features. So in our system, like in our BookMyShow system, which condition we should choose? This is the whole question. Now, let me just give you an example here. In my opinion, we should go with the pessimistic. So, if you will see the table, here is the fourth point, that is of serializability. That is saying there is no dirty read, no repeatable read, and no phantom read. It means it is prone to everything. Okay, it is highly pessimistic. It will, if you talk about the pros, it will simply saying that prevent double booking. There is no going to be dirty read. Okay, it will prevent the double booking. Second point is lock the seat during bookings. Okay, if the seat is going to be blocked by user one, then series where the pessimistic lock is giving you an insurity that other person will not going to make a dirty read on that. There will be no chances of a repeatable read and everything. The seat is going to be locked, and the pessimist is going to provide you a row level locking on that particular seat. So everything is going to be pretty sure that it is going to be safe and secure. Now the cons is there will be a chances of a deadlock and slow. And like I explained everything in my playlist. Now, what is the problems? Let me just tell you in the concept 6. Okay. So I directly move from concept 4 to concept 6. Why we need pessimistic? Why we didn't go with optimistic lock? So let me just take an example. Suppose there is one user wants to book, like this is a row 1 to 11, and in this row 1 to 11, user 1 wants to book the seat from 1 to 6, and user 2 wants to book the seat from 11 to 6. In that scenario, what will happen? So first of all, user 1 will get the request and user 2. So now what will happen? User 1 will take the lock on first one, it's fine. And user 2 started the taking lock on 11th, and it's pretty fine. User 2 on 2, 3, 4, 5, and at the same time 7, 8, 9 and 10 by the user 2. They both are taking the locks, and they are particularly like these both the situations are fine. User 1 is taking the locks on 1 to 5 and user 2 is taking the lock on 7 to 11. Now comes the scenario of the 6th row. What will happen for this? We need some sort of a range locking in this scenario. And who is going to provide the range locking? Only one piece here will get the range lock, that is in the pessimistic series, or like in the fourth point, serializable phantom read. Okay, the phantom read means range lock. I already explained it in my concurrency. So only the serializability that is going to be provided by the pessimistic, highly pessimistic lock. But it again comes with some of the problems and we have to deal with them. But can we go with the optimistic also? Maybe we can go with it as well. We're going to see how. Okay. But in my scenario, we are just simply going with the pessimistic lock because we need the high, like we also need the range locking in our scenario that I just mentioned. We want to lock directly from 1 to 6. Okay. Instead of getting single row locking, and that can cause the error later on. We can just simply go and say, I just want a lock from 1 to 6. Okay. And you want a lock from 6 to 11. Simple as that. We cannot go one by one. If we go one by one, then it can cause a problem. So now let's understand the concept 5. It is related to UI. So whenever a user is going to reach to the state where he's going to click on the seats, so how is going to see that the seat is free, booked or locked? Like there are 3 parameters that we have discussed, booked. Then how the user will be able to figure it out? Let me just tell you. So like this is a theater ID, it is screen ID, blah blah, we can fill anything, but inside it there is one seat ID. Let me just write it down. Let's the seat ID 123, and currently the status is free. Okay, so what the user will see in that scenario, that user can click on that seat. So what is the logic behind it? Whenever the status is going to be free on all the seats, like on all the seats, we'll just run the query, and whenever this we'll see the status is free, we'll just see like these are that seats are going to be clickable. And whenever the status is other than that, like it is going to be logged or booked, we cannot click them because either they are logged or booked. So what will happen when the status is free? And the user ID is going to be null in that scenario because there is no one on that particular seat. Start time is going to be null, and end time, expiry time is also going to be null right now because that seat is currently free. And what is the logic? We'll just simply say select star from that particular like theater ID and screen ID, show me all the seats, and where status equals to free, we'll just mark them like these seats are going to be clickable, and all the other seats that are going to be logged and booked, In that scenario, they are going to be grayed out. Now, the second point. What happened? After that, that user click on that seat and click on the book button. In that scenario, what will happen? How the DB will change? The DB will look something like this. We'll mark it as logged. We'll pass a user ID. That user ID will like 123 user has logged that seat, and start time and the expiry time. Now comes the point, why are we storing the expiry time here? The reason is either if our like it is a popular show or like a popular movie or something, like there is a lot of bookings. So can we move it to Redis or something like that? Or this system don't require Redis right now, or a caching thing. Okay, we'll see this particular thing in our next video, but let's go with our direct database. And in our database, we need an expiry time because this particular seat is going to be logged for 10 minutes. Okay, now what happens? There is one more thing we can stop, there is one more thing we can store, that is x, and instead of expiry time we can just store 10 minutes like x, and then after that we can compute. There can be different approaches, but I'm just storing x and x plus 10. We're directly storing the timestamps. But there is a problem. Let me just tell you in this whole approach. The problem is, that's a very simple problem. Like there is a time range x to x plus 10 where status is logged. But in that time range x plus, the user one didn't make any transaction. For that 10 minutes, user is not going to make any transaction. And after that x plus 12, like when there is a time of x plus 10, when that user 2 is going to see the screen, what the user 2 is going to see? It is going to be again grayed out, because our query was when status equals to free, but we didn't change the status. Status is still logged. In that scenario, what we are going to do? So what we have to do right now, there can be multiple ways to solve this problem. The first way is going to be either when the expiry time is like more than, like our current time is more than the expiry time, then we can run some stored procs on this table and we can change the whole like status from log to free. There can be some DB triggers. We can run some crons to update on the table, but this is going to be overhead on the system. We have to make all these things, stored proc, DB triggers and crons. So there can be one more query that we can do. When the status is not equals to booked and time is greater than the expiry time. So time means current time. Okay, so this is going to be the right query instead of status equals to free. So status equals to free will not work, my friends. Status equals to free will not work. Status not equals to booked and time is greater than expiry time is going to work. So now let's discuss the final design of this whole ticket booking system of movies. So it is not that difficult now because we have understand so many concepts before building this final design. So this one user goes to the load balancer. After that, reaching to a load balancer, it will going to hit some event services. So in the event services, I just discussed that what will happen, you can just see the movies and you can see all the theaters and everything like a search bar that we have discussed it here, and the data is going to be stored in our centralized database. So in that is going to be our MySQL and Mongo. In the Mongo we are storing our movies, in our MySQL we are storing all the other tables that we have discussed. So what will happen, user can go search the movie, show the details, like user can view all the details of the movie with this help of the MongoDB, and now user will go to the particularly going to the clicking on the movie, and after that going to book the ticket. So our request will come to the order service. The request will reach to the order service, and after that request will reach into the order service, it will go in our database that I want to book the particular ticket. So the request will look something like this: theater ID, screen ID, seat ID, and the user ID on which the action is going to be performed. After that, the MySQL, we are just going to perform pessimistic log, and we are going to log that particular row, and there is no action going to perform. We'll mark the status is going to be logged in that scenario. After that, when this particular seat is logged, all the other users, user 2, user 3, if they want that particular seat, it will look gray out to all of them. And now it will be a log of, like there will be a start time and expiry time of 10 minutes. You can do the payment and get the ticket. Now after that, what will happen, user will do the payment, like payment page will open, user will do the payment in 10 minutes. The payments is going to be stored in MySQL in the notification service, and after that when you will get the tickets, it is pretty simple. You will get the ticket, you will get the notification, and all the metadata is stored in like non-relational database. the notifications going through the queue, that are the separate mechanisms. Okay. And all the images that you are going to see on that particular website is through the CDN. All the images is going to be like a content delivery network. You can just simply saw that images. So this is a very simple designs. The most important thing of this whole video are the concepts that you need to know before studying all this. And this is something the interviewer also wants to know about this movie ticket system. So thank you for watching me, and in the next video we are going to study about the event ticket booking system that is going to be having more concepts and more algorithms. So I want all of you to stay tuned and learn deep system design. And thank you for watching me, and bye bye.